Hello, Professor Lohman. This is test 1, question 9. We'll start with part A. So, question A says, express the vector v as an ordered triplet of values separated by commas. Okay, so we can see that we're given t and u in the coordinates, and those coordinates are given the x, y, and z components for t and u. And we can see that t and u is the vector product for the value of v, which is important. So we can use the components from t and u to find the components for v. So let's start by writing out the components for t and u. So t of x equals 3, t of y equals 1, t of z equals 0. And then we go to the values of u. U of x equals 2, u of y equals 4, and u of z equals 0. Okay, here we are. Now that we have that, we can use the formula to find the values of v of x. So v of x is going to be equal to t of y times u of z minus tz times u of y. And we can find that by now plugging in the numbers. So we can see that t of y is equal to 1, and u of z is equal to 0, minus t of z is equal to 0, and u of y is equal to 4. So that's going to equal 0. So the component for v of x is 0. Now we go to v of y. So the component for v of y is going to be equal to t of z times u of x minus t of x times u of z. We can plug those numbers in and get the result. So t of z is equal to 0, u of x is equal to 2, minus, then we can find that t of x is equal to 3, and u of z is equal to 0. So we find that the vector component for y is also 0. Now we find the last one for the vector. We find the component for v of z, and that is going to be equal to t of x times u of y minus t of y times u of x. Okay, now we plug those numbers in, and we see that t of x is equal to 3 times u of y, which is equal to 4, minus t of y, it's just equal to 1, and u of x, which is equal to 2. So that's going to, 3 times 4 is 12, minus 2, that's going to be 10. So the vector component for v of z is 10. We can write these out in a coordinates, and we'll see that the coordinates are 0, 0, 10. Now I'll move on to part B. Here we are, and now we move on to part B. So the part B is to find the magnitude of vector v. So to find the magnitude, we're going to have to use the formula, and we're going to use the components to find the magnitude. So the magnitude is going to be the square root of v of x squared plus v of y squared plus v of z squared. So we plug those numbers in, and we will get 0 squared plus 0 squared plus 10 squared, which that's just going to equal 10. So the magnitude for vector v is 10. Now we move on to part C. Part C says, find the sine of the angle between vector t, and vector u. Okay, so part C. Okay, so we know that the magnitude for a vector, let's say v, is equal to the magnitude of vector t u times sine theta tu. So by doing some simple mathematics, we can switch that around, and we can divide by the magnitude of t and u and find the sine theta t of u, which is what the question is asking for. So we already have the magnitude of v that we found in question question B. So we know that equals 10, and now we need the magnitude Now we need to find the magnitude of t and u. So we'll plug it into the equation that we used in the above problem. We'll do the square root of the components of t. So it's 3 squared plus 1 squared plus 0 squared. That's going to equal to the root 2. Square root of 10, sorry. Now we're going to find the component, the magnitude of u, using the components of u. So we do the square root of 2 squared plus 4 squared plus 0 squared. That's going to be equal to 16 plus 4 is equal to root 20. So we have root 20. So we put that in here in the denominator, root 10, root 20. And when we plug this into a calculator, we find that the answer is equal to 0.707. Okay, that has been problem question 9. Thank you for listening, and have a great day.